Uh, Dear participants, friends, a very good afternoon to you all. Welcome to the session number 2 of this day 4. We have with us a very distinguished guest, Dr. P. V. Ramana, sir. Dr. P. V. Ramana is presently working as Professor in Mechanical Engineering and Dean Research and Development. He is Head Aeronautical Engineering Department at Sardar Vallabhbhai Patel Institute of Technology, Vasad. He holds PhD and MTech in Mechanical Engineering with specialization in heat transfer and thermal power from Indian Institute of Technology, Madras. He did his bachelor's in mechanical engineering from BVM Engineering College, Sardar Patel University, Vallabh Vidyanagar. He has about 10 years of industrial and research and development experience in the field of renewable energy before joining the teaching profession. During his 25 years of teaching experience at SVIT Vasad, he has taught several undergraduate and postgraduate courses in mechanical engineering, particularly thermal steam courses. He has over 61 research papers published and presented in international journals and conferences to his credit. He is principal investigator of Good Coast funded research project on coating and its erosion characteristics on boiler steels, and also worked as co-investigator in 2 DST New Delhi funded research projects during his tenure at Prairie Vallabh Vidyanagar. He is also working as reviewer for several national and international conferences and peer-reviewed journals. His major area of specialization are thermal systems, heat transfer, CFD, renewable and non-renewable energy, and thermohydraulics in porous media. He has contributed 2 book chapters to Springer Lecture Note series on advances in smart grid and renewable energy. He holds life membership in many professional societies like Indian Society of Technical Education, Indian Society of Heat and Mass Transfer, etc. He is also guiding several research scholars for their doctoral degree at Gujarat Technological University, Ahmedabad, CVM University, Vallabh Vidyanagar, CU University, Vadhavan, and Charusat, Changa. He has a technology patent on natural draft gasifier systems to his credit. On behalf of the organizing team, on behalf of all the participants, I welcome you, sir, and request you to proceed with your session, sir. Please, sir.
Thank you very much, and warm welcome to all of the participants as well as the organizers. And especially thank to organizers for providing this opportunity to interact on this forum with all the faculty members and various interested participants. And today, I also congratulate them for successfully handling this particular FDP, that is AICT Training and Learning, Atal Online FDP and PDP on buried energy for conservation and energy management. Okay. So that is also very much related to my topics of renewable energy, wherein I have worked, and also one of my PhD student, Dr. R.D. Patel, also worked on this particular work, and in the tomorrow session he will be also talking on this more. That is what we have attempted for contribution in this particular area, because this geothermal energy, when we are talking about the buried energy, so the major thing is the geothermal is there, and other fossil fuels are also there, but main content, if you consider, that is the from the buried energy concept, so we can think of geothermal, that is the major thing. And with this, once again I congratulate the organizers, and we'll start the session. Briefly, we'll be going to do the introduction to the geothermal energy and various opportunities and applications, and also how we can link that to energy conservation. Energy conservation is a very good topic itself. It is also a very interdisciplinary topic, and every citizen of the country should be aware of these energy conservation things. And energy conservation, if you on the outset, if I talk about, so it is the reduction of the energy consumption, okay, saving of energy, like. So in this case, what we do is always, so in the energy conservation, we will try to reduce the energy consumption as much as possible. Whenever you want to reduce the energy consumption for a given application or given purpose, So how we can do that is by implementing various new technologies, or the technologies which are very low cost as well as very efficient, and also they are environmentally friendly. So these type of technologies, when they are there, if you replace them, so you will be going to save the environment as well as save the energy. So that is the one concept one has to remember in the point of view of energy conservation. And other things are like switching off lights and fans, etc., while non-use and other things are there. But the major thing is how best the available alternative energy sources or technologies for better efficiency. If you could able to link that and identify the application and modify it for the local needs, so that way we can do a lot of energy conservation. Okay, so in our case, this particular research work, what they have done, what we have done is for the air conditioning applications, because it's our country, the tropical harsh conditions in the summer, etc. So to cope up with that, always we will be installing air conditioners. So if you could replace these air conditioners, the function of these air conditioner with this buried energy, geothermal energy concept. Okay, by that, so you will be able to uh, reduce the energy consumption. So that is the way of doing energy conservation. So before going into the details of those things, I would like to touch upon some of the basic aspects of geothermal energy, that is the applications and opportunities. One by one we'll see gradually. And the talk flow is like this: the introduction and about the in general conventional, non-conventional energies and geothermal energy, and its history and applications, and types of geothermal energy uses, and also whatever the research efforts we have done, and advantages and disadvantages, what is future of this, and how we can link this for the hydrogen production. That is also one of the other topic of promising nature in future. Next, this is the introductory thing. All of you know that we are using conventional and non-conventional. This is the diagram will be there always, which is conventional and which is non-conventional. So always whatever we use at present, in a big way, so that is becomes the conventional things. Okay, so whatever we are using now, petrol, fossil fuels, petrol, diesel, etc., LPG, CNG, these gases and all, these are all when they are not available. So in the initial phases, they were non-conventional, and wind, air, and windmills, and these all type of things. So they were conventional, but the scene is reversed now. Okay, the fossil fuels, we call it as conventional. In a huge way, we are exploring that, and we are utilizing and trying to finish those resources. Okay, within a short time. That is the intensity what we are using at present. Okay. So, but even though the earth is abundant of these things, and still it is always failing our estimations. So when I was studying also, we used to say that another 50 years or so 100 years, the renewables will be going to diminish, okay, completely. So then you have to think about some alternatives. So that is the same dialogue is going on still, and we don't know, have any idea when it is going to get exhausted. But one thing is clear, that because of these things, we are having a lot of environmental pollution problems and global warming, etc. Those effects we are already facing. Okay, so in that sense, we have to shift our utilization of these energies. You have to suffice the requirements by employing the various types of renewable energy sources. And one of the best renewable energy source, apart from this wind and solar, compared to that also the geothermal, if it is available, because it is the most disadvantage is it is a site specific thing. That is one case. And if it is available, that is the best resource, you can say, because it can be utilized around the clock. Okay, once the particular well is available, or that heat content is available. And surfacial things also, it is always there. Winter and summer conditions, there will be definitely the difference of about 10 to 15 degrees from the Earth's surface layer, first layer on the top layer, to the when you go deep into 2 to 3 meters down the way. So okay, so that utilization we can do for the passive cooling applications, etc., and it can be utilized continuously. It's not like wind and solar. So sometimes intermittently it goes and come back. Okay, and also the limited time period aspects will be there in that. Okay, so that is another thing. And similarly, the solution is, that is what I am telling. We have to go on to the non-conventional energy sources or renewables. Nowadays, mostly we all have to shift to call this as renewable energy sources, which can be renewed. And that's why the geothermal also comes into renewable source, because whenever you are using that, so again you are sending it, okay, injecting back to the ground. So it is again gain the energy and coming back for our use. Okay. So that's why it is a clean and best renewable energy from the buried energy. Okay. So here what we say is we have abundant natural resources of energy that can be harnessed to produce electricity and generate heat. So the sun, wind, geothermal, voltaic, hydro, all are the energy sources. The weather is all around us and it's free. Okay. So on the top of that, it is never goes to run out. That's why it's called renewable, and it does not need to be burnt. It doesn't cause CO2 emissions. That is the first and foremost point we have to remember. So in the buried energy, the major chunk, I told you that the geothermal energy. So we will be concentrating now on the geothermal energy, how we can use it. Okay. So from the Greek word, as it is, the definition says from the Wikipedia and other Googling, geo is earth, that is thermal, generally sense it heat, okay, the temperature. And so geothermal energy is defined as heat from the earth. So we have to explore. So because in the earth cross section, if you see, so at the mantle, the magma will be there, no? A lot of high temperatures will be there. So the two planets, if you compare the sun and earth, so both will be almost at the same similar temperatures at the core level. So that is almost like 5,000 to 6,000 degrees centigrade, the temperatures they are having. And similarly, the earth is also, we are feeling that it is cool when we stand on earth, but it is internally a lot of heat is there. And it's also the core temperatures will be, you can measure it as 5,500 or to 6,000 degrees centigrade. So the geothermal energy is Earth's natural heat available inside, and this thermal energy contained in the rock and fluid filled up fractures and pores in the Earth's crust can profitably be used for various purposes. The geothermal energy is an enormous underused heat and power resource that is clean, emits little and no greenhouse gases. Okay, and it is also reliable. Average system availability will be almost like 95%, and also it is there is no dependence. Okay, wherever it is available, if that is our land, so there is no foreign dependency in this. Okay, and the structure, if you see, so almost if you take the earth, so the mantle and core temperatures, if you see, like 1200 and 6,000. So the heat content on the earth, okay, it is there. And when you look the earth temperature, you can see 99% of the planet is at temperature of the 1000 degrees centigrade. If you take this whole volume of this sphere of the earth, so almost 99% of this will be almost like 1000 degrees, and only about 1% of the earth is cooler than 100. It will be less than 100 degrees. So that particular distribution of temperature will be facing, and the upper layers of this are near to the surface layers we will be having. And gradually, when it is 6,000 and gradually it is reducing, so the average comes up to be 1000 degrees. That doesn't mean that if you dig for 2-3 meters there will be 1000 degrees. Okay, so as you go deep, you will be definitely going to get the higher temperatures. Okay, so that is the beauty of this, but only thing is exploration is little costlier in these cases. And this is the general distribution depth-wise and temperatures how you have. So okay, so you go in so many of kilometers, so then you will be going to get really a very high temperatures. And these heat as all of us know that the temperatures contained by the Earth is because of the when it is planet is formed, separated out and formed, and that heat is contained about maybe about 20-30% of heat that remain there, and the remaining thing is happening because of the radioactivity decay of various elements like uranium, thorium, etc. The energy release will be taking place that will be maintaining the remaining 80%. So that comes out to be the total heat content which is there is almost like 100%, 80 plus radiative activities, and another 20% is that is the accumulated energy, accreted energy from the formation of the Earth. Okay. So, and also some of the tectonic plates, movements takes place, and because of that, a lot of friction happens. Friction happens between the layers of the Earth. So, that lot of heat also will be generated because of that. Okay. These are all things we have to keep in mind how the energy is coming. And one thing, if you want to say about the fossil fuels which are available within the Earth, so whatever heat they can produce, so 50,000 times more than that, the geothermal energy can provide you. So only thing is that energy is very concentrated, the fossil fuel energy, so that we would be able to drill it out and utilizing it. But the quantity wise, if you compare, the geothermal is the far higher value. Okay. Next. So where you will get this geothermal energy? How to identify this? Okay, some of the geothermal reservoirs naturally you will try to find it as geysers and boiling mud pots. Okay, whenever the people move here and there in the forests and hilly areas, or when they are exploring it. So in olden days they used to find like this, and the volcanoes already know, and hot springs wherever it is there. These hot springs in olden days, because of a lot of minerals and healing values will be there in this. So a lot of people use it for bathing purpose, and because these temperatures also will be quite moderate in the lower range. Okay, so that is the availability and how to suspect these areas and to find out these geothermal resource, the points. Okay. Similarly, these geothermal reservoirs, generally the places, the permeability or porous media, porous nature of these particular hills and the land also, all these things will be, the rainwater will be going out in, and that will be stored inside and getting heated up because of the activities and temperature contained by the earth inside. Okay, so those things can be forming as thermal reservoirs because of some physical changes when it happens, and it will be appeared as reflecting as the geothermal resource, and which will be noticed by the people again. And when you do surveys, like in India, or Geological Survey of India is there, they will be always trying to identify such things and map that. So that map also we'll see further. So once if you just go through the history of that, this is way back in 1800 and 1900. The first geothermal produced electricity is in Italy. It is almost like 1904. So that is a very old technology. And in this electrical generation in the geysers, that is the area where it is US in 1922 it happened, and similarly the 600 megawatts itself by 1975 they could able to achieve. And in earlier days I told you that hot springs, low temperatures, the people use for bathing, and some of the sites which are having greater temperature potential, and they were explored for the electricity generation. Okay, so moving further, so what are the various types of applications? We know all that heating and cooling, because of the nature of the temperature variations outside the atmosphere, above the earth, in the weather. So the temperatures in summer will be shooting up, and the winter it will be lower. But inside the Earth, they maintains the constant temperatures. So those differences are there. So they will be always, if you compare with the temperature inside the Earth around 2 to 3 meters, and compare that with the ambient temperature, so there will be always certain delta T will be available in the range of 10 to 15 degrees centigrade or 20 degrees centigrade. So this can be taken as advantage for the purpose of space heating and space cooling. Okay, mostly in our applications in India, it is favorable to apply for the space cooling purposes. Okay, and in abroad, a lot of in Iceland and USA and Turkey, Switzerland, etc. A lot of places, those people are exploring it for the heating, space heating and district heating. So these projects are very much well accepted there, and they are saving a lot of energy bills, and that's how the energy conservation is taken care of there. Okay, so the thermal heat provide over 80% of the central heating needs in the city of Iceland. You see, Iceland is one of the leading country in this particular geothermal thing, and our Indian counterparts also making uh, MOUs with them for the technology transfer for the power generation aspects. Okay, from the Iceland. So, and the agriculture and aquaculture also will be there, because in the colder climates, fish growth, etc., will be hindered by these things. So, they will be generally maintaining the hot waters in the swimming baths also, no swimming pools. You know, if you in cold winters you want to take bath, then you have to heat the whole swimming pool. Okay, so which is a very expensive if you are going to for using it electricity or so. So in such cases, you can have this type of passive geothermal cooling aspect, heating aspect. Okay, and the other one is whenever you have very good source of geothermal available with you, so then you can go for the power generation capacities. Slowly building up, these are old figures, 8,000 megawatt. As of now, it is almost reaching in 2010-15 itself, it was around 10,000, 11,000 megawatt. Now I estimate about the growth is sustained in the similar fashion, similar rate. So by now it reached to around 15,000 megawatt. Okay, but none of these are on the Indian soil. Okay, so that is the drawback, and we have to explore. A lot of potential is there. We have to explore that. Now the ONGC is in talks with some Iceland company, and they are going to put up these things in Ladakh area, and where they are going for a pilot plant of 1 megawatt. Okay, so there is a very slow progress, but nevertheless, so it is going on. So hope it will speed up, and in the coming years, so we will be going to have a pilot and demonstration plant of geothermal power generation. Okay. Otherwise, the passive things like no other than power generation, a lot of projects are going on, and a lot of people are taking up their research work on these areas and trying to design some sort of heat exchangers for better efficiencies. Okay, so what is the different types of materials? So okay, so that anyhow tomorrow's session he will try to explain that how he pursued those things and achieve that. Next, so the applications, if you see worldwide in general, so what is the direct uses of this geothermal energy? So industrial process heating, aquaculture, various percentages are given here. Greenhouses, agriculture product drying is also taking place with the help of this, but is very minor, and that is only happening in some Greece and Mexico, I think. And mostly you see 33% of space heating. So this is the contribution, major contribution from the USA. USA is a big way they are using this particular thing for particularly space heating. So they are saving a lot of electricity bills. Okay. So cost of geothermal energy, why it is not taken up till now? Because The geothermal energy, if you want to put up a power plant of 1 megawatt, suppose, then what happens is it will be costing somewhere around 20 crores to 30 crores. So whereas in the coal-based power plants, etc., 5 to 6 crores per megawatt, or solar, if you take also, that is also nowadays because of the cost reduction, it is also coming into a comparable zone. Okay, earlier it used to be 10 crore or so, but now it is drastically reduced, and it is competing with coal-based power plants as far as the tariff is concerned, the cost of electricity is concerned, or uh, the initial installation initial cost itself. Okay, so the more added advantage of the solar PV is cost is comparable, and similarly the gestation period is very small. Okay, if you want to have coal-based plant, so it takes a lot of time. Similar gestation periods also will be there in geothermal. At the same time, the installed cost is very high, and that is one reason. And then the availability of source with very high temperatures. Okay, high temperatures are very limited and scarce those regions. And if you have moderate low temperatures, then we have to think about the different types of power plants. So that also scenario we will discuss in the further what type of power plants it will be going to take place. And the competitive with some fossil fuel facilities, but one must keep in mind the drastic reduction of pollution. So other advantages are there. It is very clean fuel. There is no need of burning carbon or this burning diesel and petrol and LPG gas, etc. So which is contributing in the global warming. That way, the geothermal is a very clean energy, we can say. Very minor disturbance to the environment actually. And the financing and quality, sorry. So the financing part, no, because the private partners companies, when they intervene into this, then only the boom for this geothermal energy will come, but they are always think about the profit. Okay, so how you are going to invest and what cost you are going to get the electricity out of that. Electricity production cost itself is almost 10 rupees or so. So then they always try to generate the electricity at the cost of around 2 rupees, 3 rupees, as much as possible, less than that. So then they cannot take an attempt on this particular energy immediately with a lot of fashion. Okay, so that is there. So passively it will be going on, but slowly, as this technologies improves, Iceland, as I told, a lot of technology is there with them. Okay, state-of-art technologies. So we'll get the MOE and transfer agreements, and slowly we will have a demo plant. Then we will gain the confidence. And for Indian conditions, as I told you, always will be concentrate on the cooling aspects of the space cooling. So that will be much more advantageous for us. Okay, we have a capacity of 10,000 megawatts in India also, but the tapping that capacity and realizing that into a power plant, that takes a lot of investment at this juncture. The government is very much concentrating on the wind and solar, and they are also given a target for geothermal also. In 2015, they have drafted a national policy for this development of geothermal energy in India, and also in PDPU, that is in Gandhinagar, Center of Excellence of Geothermal Energy is also started, and they have also inked a MOU with some of the international players, so that ONGC and this PDPU and Iceland people will be coming, and some of the attractive sites where towards that northeastern areas. Okay, so they want to explore it and put up some of the plants. So that is a good sign, and government is also very much targeted, and they have all ambitiously they have put up about 200 megawatts actually in those days itself. Almost 3-4 years now far gone, but there is no much development. And at least 1 megawatt pilot plant comes up, then you can think about the other things to be come up. And in Godavari Basin also, the that will be the one of the first and foremost thing. They are also speeding up the work. Let us see which one will come out quickly, so that we can say that we are also having a demo power plant on geothermal energy. So the geothermal plants are relatively capital intensive. That is what we have discussed. Okay. And now the world scenario, if you see, so there are almost 29 countries which are exploring the power generation, and 78 countries they are exploring the heating and cooling applications. And the top countries are these 10, which are United States, Indonesia, Philippines, Turkey, New Zealand, Mexico, Italy, Kenya, and Iceland. Okay. So Iceland is almost like 25% of their energy requirements are met by geothermal energy. Okay. And the countries listed above represent about 90% of the power generation. So whatever the total power generation across the world, that is what I am telling about 11,000 megawatt or so. So out of that, these 10 countries contribute about 90%. Okay, if I say 10,000, so 9,000 plants, 9,000 megawatt installed capacity is in with these countries, and remaining only 1,000 is there here and there in other companies. Okay, specifically if you want to just to spell out, the US is almost like 36,600 megawatt. Philippines is at around 1900. Indonesia is 1600, and New Zealand is around so New Zealand is around 1000 megawatt. Iceland is around 700 megawatts, and Japan is around 500 megawatts. So this is the picture across the world. And similarly, this the breakdown of electricity production in these countries, irrespective of the top countries, the total countries are taken. So the major thing is, you see, United States contributes almost like 30% here, and then Philippines, and Indonesia also is somewhat reasonable, and Mexico is also good. So this is the scenario at the world level, and because they are having some sources of energy, and they want abundant funds, and also they want to take up these Montreal and Kyoto protocol seriously, and also save the environment. So they have started investing some money and trying to get these particular energy source get explored. Okay, so one beauty is it is nothing like that solar and wind. It is not that type of intermittent and unexpected nature. It is having a continuity will be there around the clock. The things are available, so one can go for the investments in that in a big way. The share of the geothermal total renewable energy is 5.1%. Okay, that's why whenever in India we list out the solar, wind, and hydro, and biomass, etc. So nowhere it comes, because geothermal there is no percentage at all. Okay, so this total renewable in the world level, when you are talking about, that itself is coming to 5%, less than 5%. Over the last 20 years it happened, and now the geothermal, comparatively, the people are telling in 1900 initial in the century, that century, so the costs which were incurred, so now comparatively they have cut down to 50% because of the technological developments taking place. Okay, so the heat output from geothermal sources increased by an average rate of almost 9% annually over the past decade, due to mainly to rapid growth in the use of ground source heat pumps. Okay, in US I told you this, in all cold countries basically, Western countries, and they are utilizing this in a big way for the space heating and district heating. So the other sense is, that is heat pumps attached systems they are putting out, not only the simple passive thing, whatever it is available in the ground, but they are also enhancing that by using a heat pump with very less energy consumption, so they could able to survive that heating applications, okay, with less energy bills. Okay, so combined heat and power is also on the rise. That is also people are exploring, and India has a reasonably good potential of geothermal. The estimated potential of geothermal energy in India is about 10,000 megawatt, and at least maybe by down the line by 2030. So if we reach to 1,000 megawatt exploring out of this 10,000 megawatt, it is a very good for good progress we can expect. And the scenario of this India, where the sites are there and how it is, that we want to see here. So Geological Survey of India is already identified about 350 geothermal energy locations distributed in 7 geothermal provinces in the country. Okay, and those are all like the Himalayas, Sohana, West Coast, Cambay in Gujarat, and Narmada Tapi is there, Godavari Basin and Mahanadi. So these are the places where intensity of these sources are available. So they are pictorially shown here on this map. This is also the survey conducted by them. And geothermal provenances, the green marked areas which are having this scope of this. So in this Godavari Basin, I told you in Andhra Pradesh, they are exploring with the help of foreign countries, and they are going to, I think Turkey they have tie up with Turkey or so. So they will be going to come up with a geothermal plant. Okay, so this you see in 2008 itself, after the Geological Survey release and Energy Ministry when it has taken decision, the Puga Valley has been selected for trapping geothermal energy for power generation by Union Ministry of Renewable MNRE. Okay, so after this, then they are down the line. In 2015, they have made a policy also, national policy for this geothermal energy, and exploratory study is underway by this NGI and Satellite Bees, Parbati Valley, Himachal Pradesh, Badrinath, Tapon, and Uttaranchal. All these places they are trying to explore. If those temperatures are good and steam is going to come out from those things, so definitely there are scope for power plant installation. Okay. However, India at geothermal power project has not been exploited at all, owing to the reasons being the availability of plentiful coal at cheap costs. Okay, and the coal is available in plenty at cheaper cost. Why to worry about these things? But environmental things and international protocols, when they are imposing certain policies and norms and controls, regulatory controls, then only we are thinking about. But as such, the natural resources, if they are there, we have to explore it. So that is one way of going progressive way in curbing out these pollutions and save the environment. Okay. So these are all just to have this information from those geological survey point of view, and these are the fields which are explored and the estimated reservoir temperatures which are there, like maximum it is 100 to 240, it is varying. Okay, at a depth of 2 kilometers and half kilometer and various points it is 1.9, like that. So these are the things, and what is the nature of the type and who has done the survey. Okay, what type of survey they have conducted and what is the technology they have used. Then continuation to that, with increasing environmental problems with coal-based projects, now people are realizing because of the international pressures, India will need to start depending on clean and eco-friendly sources, which could be geothermal. Okay. In India, following different organizations are working. You can see here that is Geological Survey is actively there always, and National Geophysical Research Institute, NGRI, And Oil and Natural Gas Corporation, ONGC, is also one of the a big player, and they are active in establishing that I told you just now, that is Ladakh geothermal power plant of 1 megawatt initially, pilot plant, and National Aeronautical NAL Bangalore also they are involved in this, and Indian Institute of Technology, and as I told you recently they have PDPU also, PDEU I think now it is, Energy University. So they also have a center of excellence for this geothermal energy. So these are the two things just I was mentioning here. The Thermax people also will be having in the picture by taking the technology from Iceland geothermal, and will assist this particular national project, which is taken up with the ONGC, and Thermax also taking hands in that and to establish the Ladakh project. And similarly, first operational commercial geothermal power plant is likely to come up in AP with a capacity of 25 megawatt, okay, Geo Syndicate Private Limited. Okay, let's hope it will come quickly and we could able to see that. Geothermal energy and the environment. So there is people, whenever you talk about any energy source, utilizing the energy source, the people bother about the environment always. So because of that, as I told you, so these are geothermal, it is not going to be affect the much of our environmental factors. It is little damage, not even 1%, less than 1% when you compare to other technologies which are using fossil fuels. Okay, so geothermal steam and hot water do contain naturally occurring stresses of hydrogen sulfide, okay, which will smell like rotten eggs, very minor quantity, and other gases and chemicals that can be harmful in high concentrations. Okay, so at the plant level itself, you can filter out and you can leave out into the, after the further effluent processing of those gases, you can leave into the environment. But the quantity will be very comparatively very less when you compare with these gases like carbon dioxide and other greenhouse gases. And the uses also, it is determining, dictating us which type of source we have and what the use can be done. Okay, geothermal use, the temperature of the reservoir. This is a diagram which is provided here, where is temperature from 30 to 350 degrees centigrade, and the map shows that various types of utilization you can think of. Okay, so the geothermal, oil, etc. You see this binary power plants. Somewhere if you have a source of above 80 and near to 100 and above 100 to 150, 180 like that. So then you can go for the binary power plants. And if you have much more than that, then you can definitely go for the conventional power plants, what we have in general. Okay. So the diagram will help you what are the different uses of things and at what are the available temperature, like spa treatment and swimming pools and snow melting and radiators and domestic hot water, air conditioning, by domestic heating by using a heat pump, okay, and food processing, milk processing, etc., fish farming, alligator farming also the people use abroad these things, okay, concrete blocks, curing, so many things are there depending upon the range of temperatures available at a particular site. This is very much the site specific. That is the major problem with this particular geothermal. And further uses, if you discuss industrial process and power generation, that everybody knows, that is what we can do with this geothermal farming, horticulture, crop and timber drying, fruits and vegetables, the dry tomatoes in Greece and fruits in Mexico, like pineapple and other fruits. Whenever the overproduction is there, they will be drying it And similarly, milk pasteurization and dehydration, milk powder in New Zealand is made out of this geothermal energy, utilizing the geothermal energy. And similarly, other application is like use this bathing and swimming, the healing factors of the thermal waters, sacred waters. So a lot of people, if it is near to some religious place, and the people will have definitely take a bath. So I have seen these things. It near this Tuva is there in Gujarat. Tuva, this hot spring is there, and similarly Dolera we have near to that Swaminarayan temple. So they have, and a lot of people take bath at these places. Very nominal, like 35-40 degrees centigrade temperature, water will be coming out continuously. And how to extract these things, no? So how you can use this? Heat energy can be brought to Earth's surface by following ways. Following ways is directly from hot springs and geysers. If the pressure is high, so they will be coming out similarly. And if it is not, the other way is the using heat pump, geothermal heat pumps also you can use, and that's how also you can enhance the efficiency of utilization, because generally COP of the refrigeration cooling applications when you use, they have a better advantage, 1 plus COP of the refrigerator. So it will be always higher efficiencies you will have in this heat pump case, and that's why in abroad, in cold countries, this technology is very, very well taken up and they are utilizing it. And uses are broadly classified as direct use and indirect use. And direct use, hot springs, fish farms and raising plants and drying winter, the industrial heating application, if anything is there, that also can be done. And also directly you can, through this particular loop, okay, you can also take this cold and hot as per the season. And similar other direct uses already we discussed about also, and just to pictorially I wanted to show you these things. Okay, so this is the bathing, the hot springs, and similarly there is also alligator farming. Some more direct uses. Yeah, are you getting my voice? Any problem?
No, sir.
Yeah. And the
It is
direct
clear,
uses.
sir. Yes.
Yeah. So some more direct uses to show the pictures, fish farming, etc., and greenhouse applications and district heating, etc. So these are very interesting to see, but here we could not able to do much. So now it will be picking up, and a lot of architecture people and from the former beginning of the green building concept is there now. So whenever they construct any building, if the space is available in the underneath, they want to install these loops and they want to make their houses warm and cool as per the season by using these type of passive things. Okay, so these open loops and horizontal ground loops will be there, and vertical YouTube type of loops will be there, and a lot of heat pumps are picking up, as I told you, in cold countries that we can see. In 2009 itself, in Germany, 3 lakh, almost 330, means 3,30,000 ground source heat pumps were installed, okay, with 51,000 new installations in 2010. So that means a lot of market is there abroad. And but we can engineer a particular system for this, at least these type of passive applications. Definitely, it also picks up here, and a lot of air conditioner bills will be coming down. So in that sense, to keep in mind these things, we also attempted that during the PhD of Dr. Rakesh Patel under my guidance in the previous years. And so this is what the experimentation and numerical simulations and the details he will explain in the tomorrow's his session. And but here just I wanted to quickly show the what is the type of attempt we have done. Okay, so these are all there, but because we are all virtually connected, but otherwise if it is a offline thing, you would have seen these things which are installed at BNB Polytechnic, that is the venue of this particular FDP. Okay, so these things are put up there, and in detail what is his experience and how he did the experimentation, all these things we will explain tomorrow. So this is one of the application of the cooling and heating. Heating is not very appropriate for us, but cooling, you can say, for the cooling applications, he tried a lot and also installed this, and he also got the grant from Gujkos also for this purpose, to take up the research and take it further. And a demo case he can make because he has some 10 meter cube room he has established there, so where he can show the demo of this. So both the options he has tried, numerically and experimentally, horizontal buried tube also and vertical buried tube, and also with the different types of materials, because the main thing is the heat exchange between the, so because the heat available is very low quantity, because the temperatures are very low. Okay, low quality energy is available. So when it is there, so we have to have a very better heat exchange devices should be designed. So for that, as a doctoral work, he tried for the using different types of materials, like from PVC to GI to copper pipes and other things, and which is better and what is his conclusion, etc. He will talk tomorrow, and I am not much elaborating on this. Okay, just to give an idea what is the uses and at least something happening in India or not. So those who are curious, so to tell them, as well as a lot of scope is there to take up work in this, and we have to devise an engineered complete solution. Like, okay, if for my building I want to have this type of system, so what should be the design, what should be the size, what is the material, everything should be completely engineered thing. If that is there, then people start using these things. Okay, like solar rooftops, now people are using everywhere. Earlier solar hot water systems they used to have by reducing the geyser bills. Similarly, this system also will be taken up to reduce the air conditioner bills. Okay, it pains no always whenever you see your bill during the summer season. Okay, so if it is reduces your bill by 50% or 60% even, so that is a quite phenomenal amount. Okay, so these are things you can discuss with him tomorrow. So moving forward, this is one idea. People can explore this, and the payback periods also he has calculated. It was very lucrative here. So almost within 2 years you will be going to get back your cost. Okay. So these are the things. Here we don't need in Indian conditions, may not be heat pump thing not required, but we can have this in abroad. In cold countries they used to. This is the typical scenario at abroad. So wherever the heat source is available, they will be utilizing that and they circulate that to this, and they will have a small compressor that is basically heat pump arrangement, and they will be increasing the heat. Whatever heat available, it will be added up by the compressor work, and overall COP will be very good, and the output rate will be much more. Okay, so that way they are taking advantage of this, and they are utilizing for district heating applications in a big way, and saving a lot of money as well as environment also. And these are all like similar type of setups, how it looks like. Geothermal heat pumps for summer, how it looks like. So the heat, through the heat pump, the cold air will be coming in, and the room air will be, after absorbing the heat, it will go away. Similarly, the similar thing can happen for the winter heating also, because definitely the temperature changes will be there. From the ground temperature may be constant, but outside temperatures you will be always varying because of the season according to that. So you will be definitely getting the delta T difference to play with these things. Similarly, these are all just some of the installations you would like to see. A lot of houses and all. So there, lot of free space will be there beneath the house. If it is not done now, also they can do because they have a lot of space. Okay, but in Indian scenario, we have to plan it in the starting itself. Okay, because land space is required for this type of geothermal installations. But comparatively, when you compare with the solar and other technologies, okay, so the land requirements are less, very less compared to this. And if not, there is another option what we have tried. I showed you just now previously, the vertical loop, also YouTube type of vertical loop, okay, single bore. If you don't have much space, okay, so that type of arrangement you can do and explore this. So this is also to show again, once again, the heat pump arrangement. How the circuit is there, heat is collected from the underground and transported to the building when it is winter. And same thing is, heat is collected from the building and transported to the ground. So when it is summer, okay. And some places, a lot of the old mining shafts will be there now, like coal mining and all. So in that also, the water which will be percolated and that will be having certain geothermal energy source, heating will be there. So those mining shafts also can be explored, and if it is near to that, you can able to explore and use it for the space heating and district heating. Okay, that is another way of showing it. And thus the indirect use of thermal energy. Now we have seen the direct and somewhat passive heating and cooling applications. Now we'll be talking about the indirect use of geothermal energy, that is electricity generation. Okay, so electricity generation, you know already, the coal-based power plants, Rankine cycle and all. So there is nothing much to explain about. So this is the electricity generation by the geothermal power plants. So there will be exploring, the extraction well will be there and injection well will be there, two things. And the reservoir rocks holding the steam and hot water, rocks heated by magma below that is the core of the earth, near to that. Above that there is porous rocks and other things will be there. And from there you explore this steam. If it is very good steam is available, further we will discuss about that, what are the different types. And in this directly, the turbine, it will expand and it will produce the mechanical shaft power, and it is coupled with a generator, so it will generate electricity. And this water which is coming out can be sent back to the again into the injection well to replenish the water, so that you are maintaining the balance. So that's why I told you there won't be any harm going to happen, because the same quantity of water what you are taking out, so you will be again putting it back. So after reduction in temperature, so that will go and again regain the temperature. So that's why we call it as it will be available for us to utilize. So that's how we say that this is a renewable source of energy. And the types of geothermal places, depending upon the temperature, you can tell is liquid dominated plants will be there, more common with temperatures greater than 200, okay, near volcanoes and Pacific Ocean and rift zones, etc. And lower places, that is less than 150 degrees centigrade or so, without conversion to electricity, for district heating and greenhouses and fisheries. That is mostly whenever low temperature are there, no, people don't think about the power generation. Okay, it will be, intensity will be very less, so cost effectiveness is not there in that. And hence geothermal systems actively inject water into wells to be heated and pumped back out. So this is also there. If you want to extract more and more energy, you will be pumping water into that and let it get heated. When it come in contact with the magma and other rocks inside, and you will be again taking them out and this water is injected under high pressure to expand existing rock fissures, okay, and enable the water to freely flow in and out. Okay, so the type of this is a engineered case, you can say. Okay, you want to exploit that more, so that is how you are going to do that. So the advantages are, it is a renewable source, by far it is non-polluting, environmentally friendly, and there is no wastage of generation of byproducts. Geothermal energy can be used directly. In ancient times, people used this source for heating homes and cooking, etc. So the disadvantages, if you see, the only few sites have potential. That is one drawback. And most of the sites produce far from the markets and cities. That is another problem, because we cannot supply these things to the households very easily, because they will be far away. So you have to utilize it there itself, and for that also we will be having a solution. Let us discuss in the end. Total generation potential of this source is too small, okay, and there is always a danger of erection of volcano. If it is hidden, we don't know that, so such accidents are possible. But mostly these survey people already, they do all those surveys, then only they will suggest to install these things, so there won't be such dangers. Okay, and also environmental, the gases problem also, it is not much. And the capturing and using the geothermal. Most common current way of capturing geothermal is tap into naturally occurring hydrothermal convection systems containing pressurized hot water or steam. Benefits are, geothermal power plant don't have an intermediate technology to produce steam to power the turbine generators. Land needed for geothermal power plants is smaller per megawatt than for almost any other type of power plants, that is solar or coal based or oil based. So oil based is okay, but the remaining places, the land requirements will be high compared to this geothermal. The challenges already know, that's why we could not able to attempt this in India. The challenges are a lot of capital intensive, and energy can be used only areas where Earth's crust is thin, and steam or hot water sources are close to the surface. These are all luck factors. Sometimes the hot water that is pumped to the surface contains pollutants, sulfur, which must be before using into the power plant. If a particular site you have sulfur content is there in the water, so you have to take some care before using it in the and sending it into the turbines and into the power plant areas. Okay. So geothermal is used widely, that is already we have discussed. Okay, once again to sum up these things, the United States is the one of the largest geothermal electricity producer. Now we will talk about the electricity generation. What are the variations and site-specific power plant, what it says. There are three types of power plants basically we can have. That is dry steam power plant, flash steam power plant, and binary cycle power plant. These are the three things depending upon the type of geothermal source available to us. Okay. So that is the dry steam power plant. That directly the production well is there, where from you will get the steam out. That steam you can supply directly to the turbines, and then it will be producing electricity by the help of generators and the generator facility. And after that, it will be condensed and send it back to the well. Okay. So that is the simple sort of plant here we have. And the dry steam, oldest type of geothermal power plant. This is the first attempted type of technology. It is similar to our regular coal-based power plants, Rankine cycle. And geothermal reservoir contains pure steam is required. Okay, that reservoir, what type of thing, you have to test it and check for the thing. And if it is like that, then you can go for dry steam power plant. Okay, pure dry steam drives the turbine. Very rare type of geothermal power plant operating in California, Italy, and Japan. Okay. This is the next one is the flash steam power plant. wherein this production well is having mix of water and also steam at high temperature and high pressure when it is coming out. So that can be entered into these flash chambers. The steam will be separated. Okay, the brine which is there, the remaining water, and that will be going into the. So in this flash thing is required. The flash chambers are required where they will be maintained at low pressures. When high temperature and high pressure steam, when it comes further at the low pressure, further it will be flashing, and that particular steam will be taking it and utilizing. This type of things are flash type of steam power plants. Okay, so commonly used geothermal power plant, because most of the sites will be having the mix of liquid and this steam, hot water and steam will be there contains. So that's why it is mostly suitable. Whenever you see hot springs or whichever is erupting out, no, so they will be always gushing the steam and water out. Okay, so that type of plants, if you want to take up and connect it, and then you have to use a flash steam power plant for this purpose. And pressure changing system is required. That is what I told you. Flash chambers are required here, and they are also there in some places working, and mostly it will be commonly used. And most common in the sense it is the need of the hour is because most of these geothermal sites will be having very low temperatures, less than or near to the 100 degrees centigrade or so less than 100 degrees centigrade. So all these power plants, if you want to really tap it, then you have to go for the binary cycle power plant, where you will be going to the secondary fluid for the purpose of the running these particular turbines. Okay, converting that vapor. Okay, isopentane is there, isobutane. So such binary fluids you can use. Whatever the heat it is coming out, mostly it will be in the liquid form. Hot water only will be there, and that will be at higher temperature, and that will be low melting temperatures, low boiling point temperature. Isopentane vapors will be formed in this heat exchanger when it is coming closer to this indirectly, and then it will be fed into these cycles, and it can be used. Okay, any type of some of the refrigerators also are some binary fluids which are having very low boiling temperature, boiling point. So that will be very good for most of our geothermal sites. It will be definitely suitable. Okay, does not use steam directly to spin turbines. Only heat of the underground water is used. Vaporized hydrocarbons are used to spin the turbine. Hydrocarbons having low boiling points such as isopentane, isobutane, and propane can be used. No harmful gas is emitted to the atmosphere because of the underground water is never disclosed to the outside, because it is heat exchanger is there. It is indirectly the heat transfer is happening. Okay. So indirectly heat transfer is happening. So that's the worldwide accepted power plant. So one can go for all sorts of the geothermal sites where you will be having less thermal potential also. So you can think of binary cycle power plants. Okay. So it looks like the generator turbine combinations. Okay. Most of our all the mechanical engineers and electrical engineers, definitely they will be knowing about these things. And this is also another view of how it looks like. Okay, so this is the thermal power plant we have, and this is the thing where from this particular fluid, hot fluid is extracted from, and there can be a fluid recycled, and again it is coming back. Okay, so this type of arrangement can be there. So this is also another view of the power plant. Okay, so these are the some sites. So then limitations of the geothermal: lack of substantial funding So one cannot take up the research as well as even installing a power plant. So the government's determination is required for this, because these are a little bit expensive technologies as of now. So that is one of the limitations. And also drilling technology is also to be improved, because you have to go deep kilometers down the earth. And lack of proven technology for extraction and use of thermal heat. That is what I told you. The ONGC drilling, oil exploration, etc. is there, and those people also very well versed with this. In some of the oil fields, when they are doing these things, no, so they come across these hot springs also. So environmental impacts, as I told you, very minor dangerous gases may be coming out, hydrogen sulfide, etc. So nothing much from the point of view of environmental thing, but people say that it will contaminate the groundwater and poisoning the fish, etc. So that beforehand we have to check those things, if that particular water which is available from a geothermal site, whether how contaminated or what are the minerals in that, all these things should be taken care of. And there are also subsidence issues also, some places they have reported, because from the earth we are taking out the steam and other things, no, slowly. So there will be evacuation, a vacuum will happen, and there are settling down or sinking of land or subsidence. Okay, so that those things may cause. Okay, very minor are reported here. There is nothing much. Okay, this is all about, I told you about the geothermal energy, and just I wanted to throw a thought as for the future prospects. Okay, so how can we generate hydrogen? Because hydrogen economy, the green energy is also going to pick up. Okay, the EV technology, electric vehicles and all. So ultimately, whatever it is, but you will have to supply the electricity somehow. Okay, so with the EV, if you are giving electricity from coal-based power plants, and you are telling that environmental is very friendly and all these things, so that is not justified. Okay, if you are giving the power for EV vehicles wherever in the EV power charging stations, so if you are giving the energy, clean energy, if you are giving green energy, if you are giving, or the source is renewable energy, so then only it will be going to be give some impact. Okay, that we have to keep in mind. And here just a slogan I have given is, the wind energy is available when the wind is blowing, but everybody knows solar energy is available when sun is shining. Okay, that is also limited, and geothermal energy is available round the clock. Okay, I hope all of you agree, but it is everywhere it is not available, but other two are available in most of the places, and sun is also, it is almost everywhere, and wind to up to certain our extraction capacity, according to that we need higher velocity. So there are some site specific nature is there in wind energy also, but in geothermal energy it is fully location specific and site specific. But whenever it is identified and available, it will be available for round the clock, 24/7 and 365 days in a year. Okay, so that is the beauty of that. And so if we can use this technology for hydrogen production, so then it will be very useful for us to go for a very sustainable economy, because hydrogen economy is going to come up. So can we explore the possibility of producing hydrogen? Okay, so hydrogen energy is ultimately utilized in directly in internal combustion engines. You can use it. Okay, or you can use a silent technology, that is fuel cell technology. Okay, if you supply oxygen and hydrogen to fuel cell technology, it will give you electricity and water. Okay, so I would like to link up this with so that I will can throw this idea, so somebody who are interested can take up some study on these things, at least theoretical study sort of thing, and survey based studies also can be taken up. But the project we want to take up, it is very difficult aspect as of now. Okay, in this, why we are going to concentrate on this is the normal steam turbine plants in geothermal also. We have talked about the power plants. They are also working on the way principle of the Rankine cycle steam turbine. So those efficiencies generally, the power capacities are bigger, but the efficiencies will be falling near to 30 and 35%. Okay, somewhat gas turbine is more, but and combined cycle is also little further. But the fuel cell and hybrid fuel cells are directly very efficient by nature itself. So they are almost like 40 to 50% efficiency they will be going to give us. Okay, so that is the idea. So that for that fuel cell to run, you need to have hydrogen. Okay, hydrogen has to be given. So the fuel cell, how it works and all these things, I don't want to take much time on this because it is a already a well-proven technology. Fuel cell, if you supply hydrogen and oxygen input, anode, cathode, and membranes are there. So the electrons will flow and the unused hydrogen will come out. And similarly, the air and water will be there. So the pure water H2O will be coming out and the electrons will flow through this and it will glow. So this is what happening, and hydrogen and negative electrons so will be passing through this proton exchange membrane fuel cell. This is one type of cell where you will be using the proton exchange membrane between the anode and cathode. So when you use these fuel cells, a pure form of hydrogen is required for this. So if you could able to produce the hydrogen at a very low cost, and that too with a renewable energy source. Okay, hydrogen I can produce. If you give me electricity, I can do the electrolysis process and I can produce a lot of electricity from hydrogen from water. But the thing is, no, you are spending electricity, but we want electricity to be produced. So that is what the route we are taken up here, that is hydrogen fuel cell route. And in this route, we will be trying to, the main thing is we have to produce hydrogen, we have to store hydrogen. That is the main aspect here. So how does it work? That you already know. We have to send the oxygen, hydrogen. So the first transported to the anode of the cell, and fuel undergoes anode reaction, and the negative electrons will be coming out and complete the circuit, and they will be producing the electricity. So I am not going much about the chemistry of these things. And there are various types of fuel cells. We will be on this topic particularly. I would like to concentrate on this particular PEMFC, where the hydrogen is the fuel. Basically, we want to give some of the cells which are there, and they will be also having a lot of heat generation will take place because of these reactions. The heat generation also will take place in that. So that is also another added advantage will be there. But if you have these two cells, they are very pure form of cells. Pure hydrogen is required, and very simple type of cells. Anyone can able to construct those things. So proton exchange membrane, alkaline fuel cells, this hydrogen is required. Only electrolyte is a little different here, and the temperature is also very reasonable, moderate. Okay. So use of hydrogen fuel cells or fuel cell technology is abroad. A lot of exploration is done in India also. People are working on this. Earlier the electric vehicles, fuel cell cars and all people used to tell. Now the EVs and the battery technology is picking up. Okay, these are some of the applications. And the high electrical efficiency, that is what why I have concentrated and give you the idea of this, that is 35 to 60%. Okay, and also not limited by the Carnot efficiency. For us, these IC engines and heat pumps and refrigerators, whatever it is, will be limited by the Carnot efficiency. But here there is not the case. And similarly, there won't be harmful emissions, as you know already, the exhaust which is coming as water vapor. And so 3-in-1 device in the sense energy efficient, environment friendly, and fuel flexible in the sense hydrogen and other CO and methane, etc. Some of the cells are developed and which can work on different fuels also. But what we are talking about is hydrogen production and PMFC. Okay, quickly I will just go through the technology. Hydrogen production is the main aim. Can we link this with the geothermal? That is what I would like to talk about. There is a thermal process and electrolytic process and photolytic process are there. These are the three processes, and I will be concentrating on the thermal type of process, the solar and geothermal assisted zinc production for hydrogen generation. So that is what the process I am talking about. Other things I am not touching here. And this is the storage, liquid hydrogen has to be stored. That's why I told you in the beginning itself, the geothermal will be very remote locations, it will be there. And that's why the problem of having setting up that and transportation of the fluid, the electricity, etc. is very difficult. In that case, if any such plants are there where you can use that heat and convert that into hydrogen, and you can store in these vessels, and you can ship this hydrogen to various places or fueling stations, and you can store that, and you can easily have a good distribution network for this. And then whoever fuel cell car is having, then you can supply the hydrogen to these people. And in this, there is a one process which is attractive for us, that is thermochemical production of hydrogen. Okay. So if you have a solar concentrator with heliostats and all, these solar reactors, initially it has to develop a temperature of 1900 degrees centigrade. If that is the case, that solar energy we will utilize at the site, and we will able to zinc oxide is there. In nature, zinc oxide is plenty available in India also. Okay, zinc oxide will take and we will expose that to these particular very high temperatures, and then it will be split into zinc. Okay, zinc pure form of the zinc is available. This solid zinc, when you take it, okay, so then again if you mix it water, so what happens is zinc oxide is affinated. Because of the affinity, it will be made zinc oxide again, ZnO. Okay, so that pure hydrogen will be available for us in this process. There are two steps. One step is zinc oxide breaking into making the zinc pure zinc by very high temperature process, which can take the help of solar reactors. And then the other one is a low intense process where you require only about 250 to 300 degrees centigrade. So that can be taken care of any of these geothermal power plants, where you will have the moderate to high temperatures around 180 to 250 degrees centigrade. In that presence of that high temperature in the heat exchanger, if you put the pure zinc and some water into that, so then because of that temperature, the reaction takes place and the pure zinc will become zinc oxide, and that can be recyclable. Again, you can recycle it, and in between whatever water you put, out of that some hydrogen will be coming out. This hydrogen you have to gradually store it. So one advantage is in geothermal, it is year round and whole day round the clock you will be having. So continuously if you produce hydrogen like this at a low cost, there will be some running cost and all will be there. Okay, equipment and labor, etc. So that we have to work out, and how this model works. So that we have to see. So this high temperature things, you can have the solar resistance, or if you go for some any other sort of waste heat available in some of the industries, etc. That also can be done. And these two sites can be different. Okay, so the high temperature process, making of zinc, pure zinc, you can do at some site, and you can transport that zinc to the geothermal site where the high temperature water is available. Okay, so that is what the text I have explained here. So the Zn is mixed with water under the geothermal source at a temperature of 350 degrees. The oxygen inside the water recombines with the zinc and produce zinc oxide once again, and the byproduct is pure hydrogen. Okay, so this works out economical and feasible technologically. One has to take up the study of feasibility with these things, and then we can easily come up with a good technology for production of hydrogen, free of cost, environmental friendly, and also it is a renewable source. Okay, so in future, if these things clicks up, then you will be having hydrogen powering fueling stations. Okay, now India is gearing up for having the charging stations. You know already that. Okay, so these are the things I would like to share with you today on this occasion of Atal FDP and buried energy conservation and energy management. Okay. So if you have any queries, you can reach out to me on this email address. We can discuss and be curious to work with you. Yeah, thank you very much. That's all from my side.
Yeah, thank you very much, sir. Sir, there are a couple of questions from the participants.
Correct.
Doctor,
Can you read out?
Sorry, sir.
Yeah, can you read out those?
Yes, sir. Yes, sir. Please. Is 1900 degree centigrade temperature can be achievable in thermochemical process to get hydrogen by solar heat only? This question is asked by Professor Variya Rajendra Babubai, sir.
Yeah, that is very difficult thing to achieve these temperatures, but people have achieved that up to 2200 degrees centigrade. The system of the heliostats and concentrators, no, as in the picture also I told you, there will be one tower and all the concentrators will be concentrating on that. So definitely these temperatures are achievable. Okay, but the whether how far they are cost effective and what is the quantity of heat they are going to generate, how much zinc oxide they can process so that zinc and oxygen will be get separated at these high temperatures. Okay, so if in some of the industries in their metallurgical or material steel industry, etc., if these temperatures are prevailing, so there also we can take the help of that. But in solar, people have demonstrated worldwide in some places these temperatures are achievable. Okay, not practicable, you can say that, because everywhere you cannot maybe construct those systems because they are not very cost effective. Is it okay?
Yes, sir. So one more question. Which are Indian sites having geothermal potential? This question is from Professor Samir Rawal.
Yes. I told you that in the picture also I told you there are few sites are there, but mainly the high temperature sites where you can propose this particular power plant. Okay, so that is there in Puga Valley. It is there, and they are exploring now with the help of ONGC. Okay, government is also very much determined, and they are trying to set up an pilot power plant of 1 megawatt geothermal power plant, and later they are going to, their plan is to go up to 200 megawatt. The potential is there. Okay, and similarly in Godavari basin it is there, and other places like in Gujarat, like Cambay and Dholera, etc., the temperatures are low little bit. They are also can be explored, but only thing is we can go for the binary type of binary power plants, so that technological aspects also there, and we have to tie up with those people already well versed with these things like Iceland and Turkey, etc., US. So people are looking at those things, and the sites are there. We have to explore it.
Thank you, sir. One more question from Vineet Modi, sir. That solar furnace to produce zinc is available in India?
Solar furnace to produce zinc?
Zinc.
Yeah, zinc production people have tried little bit, but the problem is no, the hydrogen drive is not that much. So now the technology itself you want to change, like no hydrogen cars and all coming up and all. So in those cases we can explore, but here also again we have to elaborately study the cost effectiveness of hydrogen production. There are several ways of producing hydrogen. But which one will be the cost effective and which one will be the renewable or green energy side which is there. Okay, so that we have to work out. In Israel, it is there. It is some of the people are working on this in Israel. And India, I think nobody attempted in this. In a very small scale, they have attempted, but there is not in full scale. People are working on this. Okay, because there is two steps. If the zinc oxide is there, plenty of zinc oxide is available in the natural form in India. But only thing is we have to make it to zinc first. Okay, if zinc is available directly, that is very good. And any solar system, simple concentrating system also can be utilized. Passively means whole day, whatever the sun is available, so it will be producing continuously the hydrogen, and hydrogen when we get accumulated and it will be compressed and kept it in a store. This particular technology, the hydrogen is, the storage is easy. Okay, like in solar thing, we could not able to, we are feeding to grid, we were not able to store it because batteries are expensive and very lot of maintenance will be there and all. So this hydrogen technology, if you have, so that's why earlier presentation also I suggested in some places, that is the excessive electricity which is available at various wind farms, similarly the solar farms, because in some of the peak load conditions and off load conditions, some of the electricity is getting wasted, suppose. So they could not able to feed or distribute it. So all those things can be identified at the site specific in these solar and wind farms, and can be have a direct electrolysis process. You can convert the electricity, because that electricity you cannot store because you need to lot of have batteries. But if you use that electricity and produce hydrogen from water, and you can store it, so that can be utilized anytime. Okay, so that is the idea behind going for hydrogen. So we have to thoroughly study about these things and explore these. It definitely in future we have to forcefully we have to do these things.
There's a question from Dr. T. Ravi Kiran sir.
Okay.
Which type of fuel cell is ideal for space applications?
Yeah, in space applications, when you talk about, so we have to identify the lightest type of cells, and because the simple cells only they suggest in that, because the temperatures also should not go shoot up there. So PEMCs or AFCs they will be going for, as for my knowledge.
Yes, sir. Thank you, sir. So these were the questions from the participants.
Okay.
Participants, if you have any more questions, you can post them in the chat box. So on behalf of the organizing team, on behalf of BNB Institute of Technology, and on behalf of all the participants, I thank you, Dr. P. V. Ramana, sir. I extend my heartfelt gratitude for accepting our invitation. And I thank you from the bottom of my heart for sharing your valuable time and your experience and knowledge with us. So, thank you very much, sir.
Yeah. Thank you very much, all of you.
Thank you, sir.
All
Thank you very much, sir.
all the best. Thank you very much.
Thank you, sir. Thank you, sir.
See you.
Yes. All the participants are requested to join at 2:45. Our next session start from 3 o'clock, sir. Please.